Welcome to Advanced Learning Tutoring. This is the Physics playlist. Please like this video and subscribe to our channel. The particle model of matter and density of materials. Particles can be displayed in diagrams for solids, liquids and gases. We need to know how to describe the arrangement, motion and forces for each of the particle models. In solids, the arrangement are that the particles are tightly packed in a regular structure. The motion is that the particles vibrate on the spot. The forces in solids are strong. There is a strong force of attraction between the particles. In a liquid, the particles are tightly packed but free to move past each other. This explains why liquids can be poured and that they can flow. In gases, particles are spread out and move in random directions at random speeds. There is space between the particles, so the particles can move into free space, which explains why gases can be compressed. There is little force of attraction between the particles. Density is a measurement of mass per unit of volume, and density can be calculated by doing the mass divided by the volume. If the mass units are in kilograms and volume units are in meters cubed, the units of density will be kilogram per meters cubed. Be careful to always check your units and make sure they are consistent. Density, required practical. A student wants to calculate the density of two objects shown in the diagrams below. The objects are that of a regular metal cube, where all of the sides are the same length, and an irregular object, in this case a small statue. An irregular object is one in which the sides cannot be measured to find the volume. Describe the methods that the student should use to calculate the densities of the two objects. We recall that density is mass divided by volume, so we need to explain how we can find the mass and the volume of each of the objects. Measure the mass of both the metal cube and the statue using a balance or weighing scales. For the volume of the metal cube, measure the length of the cube's sides using a ruler. Calculate the volume of the cube by doing the length times the width times the depth. For the volume of the statue, immerse the statue in water in a Eureka can and measure the volume of water displaced. The volume of water displaced is the volume of the statue. The volume of an irregular object can also be found by submerging the object in a measuring cylinder, recording the volume of water at the start and after the object has been submerged. Subtracting these values will give you the volume of the statue. Calculate the density for both by doing mass divided by volume. Changes of state. Changes of state are physical changes or physical reactions which differ from chemical changes because the material recovers its original properties if the change is reversed. During a state change, the mass is conserved. Changing a solid to a liquid is called melting, a liquid to a gas, evaporation, a gas to a liquid, condensation, a liquid to solid, freezing. A solid can be changed straight into the gas form in a process known as sublimation, and a gas to a solid by deposition. A graph can be plotted of time versus temperature when you are heating up a substance. If, for example, you have a beaker filled with ice cubes and you heat up the beaker, recording the temperature over time, what we see is an increase in temperature and then a constant temperature. The constant temperature maintained is a changing of state. Internal energy. Energy is stored inside a system by the particles, atoms or molecules that make up the system. This is called internal energy. Internal energy is the total kinetic energy and potential energy of all the particles that make up the system. Heating changes the energy stored within the system by increasing the energy of the particles that make up the system. This either raises the temperature of the system or produces a change of state. Specific heat capacity. If the temperature of the system increases, the increase in temperature depends on the mass of the substance heated, the type of material, and the energy input into the system. The specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. You were given the following equation on the physics equation sheet. The change in energy equals mass in kilograms times the specific heat capacity in joules per kilogram per degree Celsius times the change in temperature. An example question: to heat the water in the tank from 50 to 58 degrees Celsius, an immersion heater transfers 4,032 kilojoules of energy to the water. Calculate the mass of the water in the tank. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. The first thing to note are units. The units of specific heat capacity are in joules per kilogram degrees Celsius, but the energy is given in kilojoules. These two units need to be consistent. Therefore, convert the kilojoules into joules by multiplying by 1,000. Our equation becomes 4,032 times 1,000 will equal the mass times 4,200 times 8. The mass is 4,032,000 joules divided by 4,200 times 8, giving us a mass of 120 kilograms. Specific latent heat. The specific latent heat of a substance is the amount of energy required to change the state of 1 kilogram of the substance with no change in temperature. The specific latent heat of vaporization is the energy required to change 1 kilogram of substance from a liquid to a gas. The specific latent heat of fusion is the energy required to change 1 kilogram of substance from a solid to a liquid. Be aware in exam questions, if they are asking specifically about a substance changing state, then you use specific latent heat data. If the substance is purely increasing or decreasing in temperature by either heating or cooling, you will be using the specific heat capacity data. If the question states that you have a combination of heating a substance and boiling it, you will be using specific heat capacity data alongside specific latent heat of vaporization data. An example question of specific latent heat. When a kettle boils, 0.018 kilograms of water changes to steam. Calculate the amount of energy required for this change, and the specific latent heat of vaporization of water is 2.3 times 10 to the power of 6 joules per kilogram. Energy equals latent heat multiplied by mass. So 2.3 times 10 to the power of 6 multiplied by 0.018 kilograms. It is important to note at this stage that your units of mass need to be in kilograms. Multiply these numbers together to get 41,400 joules. The particle model and pressure. Motion in gases. The molecules of a gas are in constant random motion, random being a key word when describing the movement of molecules in a gas. The temperature of the gas is related to the average kinetic energy of the molecules. Changing the temperature of the gas held at constant volume changes the pressure exerted by the gas. The volume must be constant because if you compress a gas, reducing the volume, it increases the pressure. Increasing the temperature of a gas causes the particles in the gas to gain kinetic energy. This causes the number of collisions with the walls of the container to increase, thus a pressure increase. To note, at this stage, pressure is defined as the number of collisions with walls of a container by particles. Pressure in gases. A gas can be compressed or expanded by pressure changes. Pressure produces a net force at right angles to the wall of the gas container or any surface. Explain why increasing the volume in which a gas is contained decreases the pressure. Increasing the volume at a constant temperature can lead to a decrease in pressure. The gas particles have more space to move randomly, therefore fewer collisions with the walls of the container and a lower pressure. The formula P1V1 equals P2V2 must be learnt for this exam. This means the original pressure multiplied by the original volume will be equal to the new pressure times the new volume. You can use this in the following example. At 50 kilopascals, the volume of a gas is 0.008 meters cubed. Calculate the pressure of the gas when the volume is decreased to 0.00016 meters cubed. Before we do the calculation, we think if the volume of the gas has decreased, we are compressing the gas, therefore this should lead to a pressure increase. So our final answer should be greater than 50 kilopascals. Using the formula P1V1 equals P2V2, substitute in the original pressure and volume. That's 50 times 0.0008. Set this equal to the new pressure, which we are trying to find out, multiplied by the new volume of 0.00016. Pressure in gases. Work is the transfer of energy by a force. Doing work on a gas increases the internal energy of the gas and can cause an increase in the temperature of the gas. The pistons in a diesel engine work by compressing air and then spraying in droplets of diesel fuel, which then ignites. Explain how compressing the air increases its temperature until it's hot enough to ignite the diesel fuel. When the piston presses down on a column of gas, it applies a force that moves a piston a certain distance. They have done work on the gas by compressing it, very similar to pumping up a bike tyre. As work done equals force times distance, since the volume of the gas has decreased, the pressure has increased because the particles are moving in less space and collide more often. The increased pressure leads to an increase in temperature. This is because the temperature is a measure of the average kinetic energy of the particles, the increase in internal energy of the gas. This means that the temperature must increase.